let's have a look at our multiple choice. Again, a standard question. We've got a bit of snapshot of a graph there. Which of the following could be the derivative function? So what I notice about this function here, it's got a positive gradient to the right of the axis, a negative gradient to the left, and at x equal to 0, the gradient of my line is approaching infinity. So which of those has, so if I'm looking for f dash of x, I'm looking for where my gradient, so if I match off my green section here I've got an increasing or a positive gradient, so I want the function line to be above the axis, which is there. All of them are above the axis there, so they represent positive gradients. Okay. It needs to be a negative gradient to the left, okay, which is there, not there. So I don't know why B is circled. So negative gradient, not there. So that gets us down to, let's write that out. That gets me down to a choice in 3, okay. The other part of it was at x equal to 0, the gradient should be approaching infinity. And well, actually it should be approaching, infinity negative or infinity positive, yeah? So on the right-hand side, it's approaching positive infinity. On the left-hand side, it's approaching negative infinity. So C is our answer. Question 2, there's our graph. The graph showing stationary points occur at -1 and 2. So I've got my stationary points marked in there. So there's a stationary point at -1, there's a stationary point at 2. The rate of change of f. Rate of change is the derivative, isn't it? So where is the derivative positive? Where is the gradient positive? So you've got that blue section of line, the gradient is positive. So from negative infinity to -2, that should be a negative. Oh, -1, sorry, good. There's my -1. And from +2 to positive infinity, it's also positive gradient. All right? So the only one of those that satisfies that is E. Question 3, really straight on the CAS. Solve f dash of x is greater than 0, which will give me a positive gradient. And if you solve that on the CAS, you get negative root 10 on 2 is less than x, which is less than 0, or x is greater than 10 on root 2. And that 10 on root 2 turns out to be 1.58. And so D is the response we're looking for. Okay, same sort of thing as the first question. What could the derivative graph look like? So again, if we consider the gradient of the line, where x is less than 0, the gradient is decreasing. So the gradient's got to be below the line. So I need it below the line to the left of 0, which is below the line to the left of 0, which is only those two. All right. Then between 0 and our stationary point, okay, the gradient should be above the line, and then it becomes below the line again. Okay, so it's got to go above the line, and the only one that's above the line really from that point on is B. And does it match off the next part of it? And then it becomes below the line again of where the gradient is negative. So B fits all of that. Question 5, again, another one of those nice questions where you can't use your calculator to solve it. So you've got a function f of x, another one f of x plus 1. So quotient rule, all right? So the derivative of the top. So over here I've done the derivative. So the derivative of the top, which is f dash of x, times the bottom, which is just f of x plus 1, minus the derivative of the bottom, which is just f dash of x, times the top, which is f of x, all over the bottom function squared, which is f of x plus 1 all squared. So what we do find in here is that f dash of x times f of x cancels out with f dash of x times f of x to leave me with 1 times f dashed of x, which is that expression there, over the bottom f of x plus 1 all squared. And that matches off to option C. Okay, so we've got a quartic graph. Okay, ax to the 4 minus bx squared. A and b are positive, so it's a positive quartic. If I factorise that, I get x squared outside of x, ax squared minus b. If I want to solve them all equal to 0, I'll get x squared equal to b on a, so I get intercepts at the positive square root of b on a and negative square root of b on a, and we get a turning point at x squared. All right. So the rest of the question then talks about also g dash of r and g dash of s are both 0. So that's where my gradients are 0 and r is less than s. So there's r there, there's s there. So what's the question want us to find out? The function g has positive gradient. So the positive gradient is through there and through there, isn't it? So the positive gradient is from r to 0 union s to positive infinity. Oh, so there's my r to 0, not including because it's 0 at those points, and then s to positive infinity. All right. So which one does that make off to? R to 0 union s to infinity, which of course is A. Finally, question 7. On the graph of the function, the stationary point of inflection would occur at. So this is the derivative function. So what's the point of inflection? Where the gradient might be positive, 0, then positive, or negative, 0, negative. So if you're looking through here, the gradient is above the axis, so it's positive. Positive gradient, 0 gradient, positive gradient all the way through, 0 gradient, then negative gradient. So clearly negative b is where it's a positive gradient, 0 gradient, positive gradient. So x equal to negative b is my point of inflection.